Okay, and we're live.
Mm-hmm.
So we're continuing with free response questions, this time 2017. And we'll be looking at interpreting graphs of the derivative. So I've got this differentiable function f, which is not what's graphed, on the closed interval from -6 to 5, which satisfies f of -2 is 7. Our graph of the derivative of that function is here and consists of semicircles and line segments. Okay, we're going to start
Mm-hmm.
out with, it's black. We're going to start out with picking the right color, and then finding f of -6 and f of 5.
So since we know f -2, it's integration from f -2 to -6.
Integration from -2 to -6.
And then we change the sign.
Okay, of what though? What am I integrating?
F prime x
Okay.
dx.
Okay, so I've got my start point and then we'll add the change. And you're right, we'll have to change the sign in order to flip these bounds. So I can go from left to right.
Mm-hmm.
So this will become f of -2 minus the integral from -6 to -2 of f prime x dx.
Yep.
Okay.
So -6 to 2 is 6.
I think there's 4 units there, right? This is -6 to -2. So that's a 4 by 2
Yeah.
triangle.
Oh. So 4.
Okay, and f of -2 was given as 7. Add a little bit more space here so I can show what this actually is. So this is f of -6 is what I'm solving for right now. F of -2 minus that value.
Mm-hmm.
Okay, so I could say f of -6 is equal to, we said, 7 minus 4 is 3. Okay, but we also need to find f of 5. What's our general form if I want to find f of 5?
That's f -2 plus integration from -2 to 5.
Of what are we integrating?
Mm-hmm. F prime x.
F prime x dx, okay. Once again, f of -2 is given as 7. But we do need this area. So this is a semicircular area with a radius of 2, and it's negative.
Mm-hmm.
So what should that total area be?
So 2 to 4, 2 pi, no, -2 pi. -2 pi, and that's 3, 2, so 3.
Okay. Oops. So I've got plus 3 minus 2 pi.
Mm-hmm. So 10 minus 2 pi.
Okay. Questions on part A?
No.
Okay. It is checked really good so far. Okay, part B.
So f prime, if f is increasing, then f prime should be a positive number.
Okay.
So -2, 6 to negative 2. And 2 to 3, 4, 5.
Okay, cool. And I can actually change these. So is negative 6 going to be open or closed?
Closed.
6. Okay, negative 6 should be open. Negative 6 is okay. We'll still be increasing since that's still a positive value.
Wait. Open means include?
Yes.
Oh, yeah, then open.
Okay, negative 6 is included. Is negative 2 included or not included?
Included.
So negative 2 is actually not included. Can you tell me why?
Oh, it's 0 at the point.
Right. Okay, what about 2 and 5?
Not included, both.
Not included. Okay. I am looking at the scoring guide now, and it doesn't look like they mentioned. Doesn't look like they did that. But if I was going to write this in interval notation for your test this year, then I could do this. So negative 6 does need to be included because my value of the derivative is still positive for that. Okay, for C. Looking for absolute minimum value.
Absolute minimum value. So that's when it changes when f prime changes from negative to positive, which is at point 2. And we have to check endpoint.
We need to check endpoints as well. Okay, so we're going to test at x equals negative 2 because we changed from
negative
we're
to
looking
positive.
for minimum.
Yeah.
At negative 2, we're changing from positive to negative.
Positive to negative? Oh yeah, 2 to 2, I mean. Yeah.
Okay, positive 2. And then our start point and end point, so that's negative 6 and 5. Okay, I believe we already have our y values there. We do. Okay, so f of negative 6 is 3. And f of 5 we said was 10 minus 2 pi earlier. Which means we just need f of 2. How can I find f of 2?
That's min f negative 2 plus integration from negative 2 to 2.
Of
F prime.
f prime x dx. Okay, so this is 7 plus, what should go here?
Negative 2 pi.
Negative 2 pi. So this is 7 minus 2 pi. Okay, we don't have a calculator for this section, but pi is more than 3. So if I do 7 minus 2 times 3-ish, I'll end up with around 1. If I do 10 minus 2 times 3-ish, I'll end up with around 4. So what's our minimum right now?
2, where x is 2.
Okay, the absolute minimum. Occurs at x equals 2. Okay. I think I do need to write some reason why we picked 2. So you told me orally, but can you tell me one more time? Why did you pick 2?
Because f prime changes from negative to positive at that point.
Okay. is either when f prime x equals 0 and changes sign from negative to positive, or the bounds of the interval. This means the start point or end point. Okay, and I think we would get full credit for that. Last one.
F prime 5, F double prime minus 5 and F double prime 3. So F double prime 5 is the slope at x equals 5, so 4, 2, so that's negative 1/2.
Okay, you're right, but I need to write some work here. So what did you just do?
0. So negative 2 plus 6. Oh, I mean upper bound. Yeah, I mean denominator.
This is a language difference, but you just gave me the denominator, right?
Yeah.
Okay.
Denominator is negative 2 plus 6. Yep, and 2 minus 0.
Okay, that works. So that's f of negative 5. So this one does exist. What about f of negative 3? Or f prime 3, rather. F prime pros.
0.
Not 0.
Oh, wait. Oh, does not exist. We can write does not exist.
Why?
Because there is no slope at x equals 3.
Can you prove it?
Because it's sharp.
Okay, you're on the right track. It is because my slope as we approach 3 from the left is not the same as my slope as we approach 3 from the right. Let's prove that analytically really quick. So this is the limit as x approaches 3 from the left. So if I go 3 from the left, then I'll need to test the slope that's gone this side. So if I do, that'll
we
be...
check slope. Okay.
Yep.
So that's 2.
Okay, then the limit as x approaches 3 from the right.
That's negative 1.
Okay, yep. I'm just going to write out my formula here for the slope. As these are not equal, f prime prime 3 does not exist. Okay. So in order to prove it, we just need to test the slope from the limit as x approaches that value from the left, and the limit as x approaches that value from the right. And if they're not the same, then we can prove that we're at some sort of a cusp for our first derivative. And that would mean the second derivative does not exist. I'm going to throw this up here. Scoring guides. Okay, we had everything for A, for B. Oh, okay, they did throw that. I just didn't see that the first time, so I was looking at this last line. But so we're okay on the open and closed parts of the interval. Considers x equals 2. Okay, and then answer with justification. Absolute minimum value here because we tested our critical point endpoints. Okay, we should be good. Just the value of f of -5 and then f3 for the second derivative doesn't exist with our explanation. We should be good. Okay. So I think we would have gotten full credit for that.
Yay.
All right. Any questions on anything from today?
Nope.
Cool. So we're going to do the free response questions part 1 and 2 for homework. Then I'll see you tomorrow for physics. And tomorrow for physics, we'll be starting some physics A stuff since we've finished off the physics C FRQs.
Okay.
All right. So thanks a lot, and I'll see you tomorrow.
Bye bye.
Bye.